morning, people. Radical Randy here, and today we're talking about simplifying radical expressions. Now, what song from Queen do skaters love? Bohemian Rhapsody! Yeah!
First thing we're going to do is review perfect squares. So remember, perfect squares are the squares of integers. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. These you all have memorized now because it's the way we break up radicals. Now let's talk about like radicals. So two or more radical expressions with the same terms and degrees under the radical are like radicals. All you have to do is make sure the radicands match. So in this case, the radicands do match. Therefore, these are like radicals. So what we can do then is add them together. So we would add the 12 and the 9 and keep the rad 3. Think about it as a variable. 12x plus 9x equals 21x. So in this case, 12 rad 3 plus 9 rad 3 would equal 21 rad 3. Here, you can see that the radicands do not match. This is 5x, this is 5y. Because they do not match, they are not like radicals, so you cannot add them together. Now, conjugates. So given that a, b, c, and d are all rational numbers, conjugates are in the form a rad b plus c rad d and a rad b minus c rad d. When conjugates are multiplied together, the result is a rational number with no radicals. A conjugate, all you have to think, it's a binomial, so you got two terms. Boom, 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 boom. The only difference between the two conjugate pairs would be that middle sign. So one is a rad b plus c rad d and one is a rad b minus c rad d. So these two are conjugates. The reason we're going to use conjugates is to get rid of radicals. So sometimes you have a radical in the denominator and you need to get rid of it. If your radical is in a binomial, you'll have to multiply by its conjugate to get rid of it, and we'll do that later. We're also going to review the vocabulary that goes with radicals. So remember that number out front is your coefficient. The number inside that little radical sign is going to be your index. If it's not there, if you don't see anything, it's a 2. Your radical sign, you know what that is, and your radicand is what's under the radical. Now quickly, let's review simplifying radicals. So if you're taking the square root of a number and it's not a perfect square, you're going to break it into two radicals where the first radical is a perfect square. That's how you simplify radicals. So if you have the square root of 180, 180 is not a perfect square. So you're going to break it into two radicals that multiply together to make rad 180. The first number has to be a perfect square. The reason is because now you can take the square root of 36 and get 6. Rad 5, you can't take the square root of that. You can't break it up any further, so it stays 6 rad 5, and that's your answer. Now, sometimes you won't use the biggest perfect square that goes into this number. Sometimes you'll use a smaller perfect square, like 9, that goes into this number. Everything will be the same. You just need to do one more step. So if you take the square root of 9, you get 3. And remember, over here, rad 20, you can break that up further. Over here, we couldn't break up rad 5 any further. There's no perfect square that goes into 5, but there is a perfect square that goes into 20. 4. So you break up rad 20 into rad 4 times rad 5, then you take the square root of 4, you get 2. So your final answer is 3 times 2 times rad 5, which is 6 rad 5. The exact same thing you got over here. It just was one more step. Now let's talk about simplifying radicals with variables. To simplify the square root of a variable with an even exponent, all you need to do is remove the radical and divide your exponent by 2. To simplify the square root of a variable with an odd exponent, you break it into two radicals multiplied together, where one has a variable raised to the first power. Here you can see we have an odd exponent. So what we do, we break it into two radicals, where one has a variable raised to the first power. These two multiply together to make this. But all we did was just take one of the a's out, and now over here we have an even exponent. So when we take the square root of a variable with an even exponent, we just remove the radical and divide the exponent by 2. That's how you get a to the 6th. This rad a stays under the radical. Boom. Here, you break it into two radicals for rad x to the 4th and rad y to the 9th. Rad x to the 4th, again, even exponent divided by 2 and remove the radical. Here, we have an odd exponent, so we break it into two radicals where one is just your variable raised to the first power. That means the other one would have to be rad y to the 8th, right? Because these multiply together to make y to the 9th. When you multiply like bases, you add the exponents. Here, this is now an even exponent, so when you take the square root, just divide that by 2 and remove the radical. This one stays under the radical because there's no way you can simplify this any further, so this is your final answer. Next, we're going to review multiplying radical expressions. So to multiply radical expressions, remember, you multiply the coefficients together and multiply the radicands together, then simplify. So here, we multiply the numbers out front together. 3 times 1 gives you 3. Multiply what's under the radical together. W to the 5th times W to the 7th. You add the exponents, you get W to the 12th. Then you simplify from there. Here, same thing. Multiply what's outside the radical together and what's under the radical together. Then simplify them separately. Dividing radical expressions. So to divide radical expressions, if the numerator and denominator have a radical, you put the whole thing under one radical, just like this. Then you simplify that fraction. Once your fraction is completely simplified, then you put the square root back in the numerator and denominator and take the square roots. Lastly, if there is a radical still in the denominator after you simplify, you need to rationalize your denominator. So you multiply the numerator and denominator by that radical. And that's only if this is a monomial. If it's a binomial, we'll get to that later on, you use the conjugate. Now today, this is what we're doing. We're adding and subtracting rational expressions. So to add or subtract rational expressions, combine the coefficients of the like radicals and keep the radicals the same. So here, we have 5 rad 10 plus 7 rad 10. When you're adding or subtracting radical expressions, think about the radicals more as variables. They're going to stay the same, right? When you add 5x plus 6x, you get 11x. You don't get 11x squared or anything. Here, are the radicals the same? Do we have like radicals? Yeah, we have rad 10 and rad 10, which means our answer is going to be something rad 10. So we add those numbers out front, our coefficients. What's 5 plus 7? That's 12. So your answer is 12 rad 10. If you have 5 rad 10s and you add 7 rad 10s, you get 12 rad 10s. Over here, do we have like radicals? Yes, rad 2x and rad 2x, they match. So our answer is going to be something rad 2x. Now, what is that something? Well, the coefficients are 8 and -1. Because there's nothing here, that's just -1 rad 2x. That's how you look at it. So what's 8 minus 1? That's going to be 7. Here, do we have like radicals? No, this is rad 3, this is rad 5. So there's no way to add these together. So your answer is 4 rad 3 plus 8 rad 5. Done. Over here, are these like radicals? No, they are not. But what makes this different than this is that this is rad 3 and rad 5, meaning that if I wanted to, I couldn't break up rad 3 or rad 5. Here, rad 75, yeah, I could break that up. I think there's a perfect square that goes into 75, and I think there's a perfect square that goes into 12 as well. So let's go ahead and try to do this. So this 2 stays out front. The rad 75, we break up into 2 numbers that multiply together to make 75. One has to be a perfect square. That's 25 and 3. On this side, the -9 stays out front, and the rad 12 is going to break up into 2 numbers that multiply together to make 12. One has to be a perfect square. That's 4 and 3. Now we can simplify this. The 2 stays here. Rad 25, we chose 25 because it's a perfect square, so the square root of 25 is 5. Rad 3 stays rad 3. -9 stays -9. The square root of 4, we chose that because that's a perfect square, so we get 2. And then rad 3 stays rad 3. So now we simplify. 2 times 5 times rad 3 is going to give you 10 rad 3. Over here, -9 times 2 times rad 3 is -18 rad 3. Now do we have like radicals? Yes, we do. And you can see we started without like radicals. And now since we simplified, we do have like radicals. So it's not always going to be exactly what you see. You have to try to simplify sometimes. This time over here, we couldn't simplify this any further, so you were done. Here, you could, and when you do, you end up getting like radicals. So what's 10 rad 3 minus 18 rad 3? Well, since your like radical is rad 3, you're going to keep that, and it's going to be something rad 3. Well, what's that something? What's 10 minus 18? That's going to be -8. So your answer is -8 rad 3.
Why didn't the surfer ride the glassy waves? Because she heard they were breaky. Example time.
Now example 1 says simplify each sum or difference. So here we have 6 rad 23 plus 2 rad 23. Do we have like radicals? Yes, the radicals are the same, so we're going to keep that radical. Now, your answer is going to be something rad 23. So what's the something? Well, what's 6 plus 2? That's 8, and you're done. Look how easy that was. Here, do we have like radicals? Yes, we do. So we go ahead and keep that radical, and then we add or subtract whatever's out front. So what are our coefficients? -4 and then +3. What's -4 plus 3? That's -1. So you can write -1 rad 19b, or you can write just a little negative out front. That's what most people do. Here, do we have like radicals? Yes, rad 11, perfect. So what we do then is we keep that radical and we combine the coefficients. So what is 5 minus 7? That's going to give you -2. So your answer is -2 rad 11. Down here, do we have like radicals? Yeah, they're all like radicals. Sweet. So we're going to combine those coefficients. We keep this radical, rad 5m, and we combine the coefficients and put that in front. So what's -3 plus 5 minus 12? That's going to be -10. So your answer is -10 rad 5m.
What did one surfer say to another surfer who was crying because they fell off the wave? Why pout? You try.
Okay, so part A, do we have like radicals? Yes, we have the same thing on the radicals, so we're going to keep that radical and we're going to combine what's out front of the radicals, the coefficients. So what are our coefficients? Negative 12 and negative 11. Negative 12 minus 11 is going to make it negative 23. Over here, do we have like radicals? Yes, we do. So we keep that radical and we go ahead and combine what's out front. So what's out front? Negative 9 plus 9, that's going to be 0. So we have 0 rad 13c. Now what's 0 times rad 13c? That's 0. So you just leave your answer as 0. Here, do we have like radicals? No, we do not. Is there any way we could break up 11? No, there's no perfect square that goes into 11. What about 17? No, both of these are prime numbers. So we leave our answer 2 rad 11 minus 3 rad 17. Over here, do we have like radicals? Well, these are not like radicals, no. What about these? Yeah, those are like radicals. So these two are like radicals. This one is not. So we can combine the coefficients for these two, the rad 2q's, but we cannot combine the coefficients for the rad 3p. So what are the coefficients that go with the rad 2q's? That's a negative 2 and a negative 15. So negative 2 minus 15 is negative 17 rad 2q. And then we just go ahead and add this 8 rad 3p to the end. Okay, example 2, doing the same thing. So first, do we have like radicals? No, we do not. But can we simplify them? Well, rad 7, no, 7 is a prime number, so there's no perfect square that goes into that. What about 63? Yeah, there's a perfect square that goes into 63, right? 9. So let's go ahead and break these up. We said 5 rad 7. Since you can't break up the rad 7, we're just going to leave that 5 rad 7 for right now. But over here, negative rad 63, you can keep it negative, or you can just say that it's technically negative 1 times whatever we have over here. So we said a perfect square that goes into 63 would be 9. So rad 63, we're going to break into rad 9 times rad 7. Now what we can do is simplify this. 5 rad 7 stays 5 rad 7. This negative 1 right here stays negative 1. The rad 9 we know turns into 3 because the square root of 9 is 3. And then rad 7 we said can't break up any further, so it just stays rad 7. Now we simplify this. We have 5 rad 7, and then over here negative 1 times 3 is negative 3 rad 7. So now do we have like radicals? Yes, we do. So we keep that radical and then we combine the coefficients. So what's 5 minus 3? That's 2. So our final answer is 2 rad 7. Part B, doing the same thing. So first, do we have like radicals? No, we do not. But can we break them up? Yeah, I think both of these can be broken up. So let's do it. Here, this 4 comes out front. And then what perfect square goes into 128? 64, right? So we can break this up into rad 64 times rad 2. Over here, this 5 stays out front. And then the rad 18, what perfect square goes into 18? 9, right? So this becomes rad 9 times rad 2. Now let's keep these going. 4 stays 4. The rad 64, square root of 64, we know is 8. And then rad 2, can't break that up any further, so it stays rad 2. Then it's plus 5. Then the square root of 9 is 3. Square root of 2 stays rad 2. Now, 4 times 8 times rad 2 is going to give you 32 rad 2. 5 times 3 times rad 2 gives you 15 rad 2. Now we have like radicals, so we keep that radical, and we just combine the coefficients. What's 32 plus 15? That's 47. And you're done.
What does the skater ride on when he can't think of anything better to do? A board! You try.
Okay, doing the same thing here. So, do we have like radicals? No, we do not. But can we simplify them? Yes, we can. We take this 3, leave it out front. The rad 45, we can break into 2 radicals, one of which has to be a perfect square. So what perfect square goes into 45? That's going to be rad 9 and rad 5. Here, this minus 8, we leave out front of that radical. And then the rad 20, can we break up that? Yeah, there's a perfect square that goes into 24. So rad 20, we break up into rad 4 times rad 5. The 3 stays out front. The rad 9, the reason we picked 9, it's a perfect square, so the square root of 9 is 3. The square root of 5, we can't break that up any further, so it just stays rad 5. We keep the minus 8 out here. The square root of 4, we picked 4 because it's a perfect square, so the square root of 4 is 2. And then rad 5, can't break that up any further, so it just stays rad 5. Now we combine these, so 3 times rad 5 is going to be 9 rad 5. Negative 8 times 2 times rad 5 is going to be negative 16 rad 5. Now do we have like radicals? Yes, we do. So we keep that radical. Remember, radical stays the same. And you combine the coefficients. What's 9 minus 16? That's going to be negative 7. Over here, doing the same thing. Do we have like radicals? No, we do not. But can we break up either of these? Yeah, we can break up both of them, I think. there's a perfect square that goes into 72, right? We take this 2, leave it out front, and then what perfect square goes into 72? How about 36? 36 times 2 gives you 72. On this side, this plus 6, we leave out front of that radical. And then the rad 8 we can break up. What perfect square goes into 8? That's 4. So rad 8 we break up into rad 4 times rad 2. Now this 2 stays out front. The square root of 36, the reason we chose 36, it's a perfect square. So the square root of 36 is 6. Rad 2 stays rad 2. The plus 6 we leave out front of this radical over here. And then the square root of 4 we know is 2. And then rad 2, can't break that up any further, just leave it rad 2. Now we simplify. 2 times 6 times rad 2 is going to be 12 rad 2. On this side, 6 times 4 times rad 2 is 24 rad 2. Now do we have like radicals? Yes, we do. So we keep that radical the same and we combine the coefficients out front. What's 12 plus 24? That's going to be 36. Now example 3, this is a little bit different. We are multiplying this 3 rad 5 to the binomial rad 15 minus 4. So we're going to have to distribute it. First, we're going to multiply the 3 rad 5 to the rad 15. So you multiply what's in front of the radicals together. 3 times this invisible 1 is 3. And then what's under the radicals together. Rad 5 times rad 15 is rad 45. Then we multiply the 3 rad 5 to the negative 4. Multiply what's on the outside of the radicals together. So 3 times this negative 4 is going to be negative 12. And then rad 5 times, well, there's nothing over here. So it's just going to be negative 12 rad 5. Sweet. Do we have like radicals where we can combine these? No, we do not. But can we simplify this one? Yes. Again, the rad 5 can't simplify that. So let's try to simplify the rad 45. So we leave the 3 out front. Is there a perfect square that goes into 45? Yeah, 9. So we break up rad 45 into rad 9 times rad 5. Over here, this negative 12 rad 5, we just leave it negative 12 rad 5 because there's no other way to simplify this. We can't break up the rad 5, so there's no point in breaking this up. Here, though, the 3 stays out front. Rad 9, we chose 9 because it's a perfect square. The square root of 9 is 3. And then the rad 5, we know just stays rad 5 because you can't break that up. This over here stays the same, negative 12 rad 5. And then over here, 3 times rad 5 is going to give you 9 rad 5. So now we have 9 rad 5 minus 12 rad 5. Do we have like radicals? Yes. So we keep that radical the same and we combine the coefficients. What's 9 minus 12? That's going to give you negative 3. For part B, we have this binomial times this binomial. And you remember, when we multiply binomials, what we have to do is FOIL this. So let's do it. We are going to multiply the rad 6 times the rad 2 first. So rad 6 times rad 2, multiply what's under the radical together, get rad 12. Then we multiply the rad 6 to the negative 2. Since this has radical, this doesn't, we multiply this to the outside of that rad 6, and we get negative 2 rad 6. Multiply the inner terms together. What's rad 3 times rad 2? Multiply what's under the radical together, get rad 6. And since it's positive rad 6, you put plus rad 6. Lastly, we multiply the rad 3 times the negative 2. Again, since this doesn't have a radical, but this does, we just tack that on the front, and it becomes negative 2 rad 3. Now we look, are there like radicals here? Yes, we do have 2 like radicals, right? We have the rad 6 and the rad 6. So we're going to keep that radical the same, and we're going to combine the coefficients that are out front, the negative 2 and this positive invisible 1 right here. So what's negative 2 plus 1? That's negative 1. So you can write negative 1 rad 6, or you can just write minus rad 6. The other terms stay the same because they don't have the same radical as we do here. So we leave this rad 12 in the front and then negative 2 rad 3 in the back. Now, can we simplify this any further? Well, it doesn't look like it, but yeah, we can break up this rad 12. Let's try doing that. So what perfect square goes into rad 12? We know 4 does. So we break up rad 12 into rad 4 times rad 3. The negative rad 6, we can break up rad 6 into rad 2 and rad 3, but neither of those are perfect squares, so it wouldn't make any difference. So we just leave that negative rad 6 and then negative 2 rad 3. Can we break up the rad 3? No, so that stays the same. So over here, this rad 4, the reason we chose 4, it's a perfect square. The square root of 4 is 2, so this becomes 2 times rad 3 minus rad 6 minus 2 rad 3. So we get 2 rad 3 minus rad 6 minus 2 rad 3. Oh, look at that. We do have like radicals now. Because we have like radicals, we can keep that the same and combine the coefficients that are out front. What's 2 minus 2? Oh, that's 0. We then go ahead and tack this negative rad 6 on the end. And what's 0 rad 3? Well, 0 times rad 3 is 0. So 0 minus rad 6 is just going to be negative rad 6. And you're done.
Who's a surfer's favorite character from The Office? The Nard Dog. You try.
Okay, doing the same thing here. So we need to distribute this 5 rad 12 to the rad 3 and to the negative 3 rad 2. The 5 rad 12 times rad 3, you multiply what's under the radical together. So 12 times 3 gives you 36. So that's going to stay under the radical. The 5 stays out front, so it becomes 5 rad 36. When you distribute the 5 rad 12 to the negative 3 rad 2, you multiply what's on the outside of the radical together. So 5 times negative 3 gives you negative 15, and rad 12 times rad 2 gives you rad 24. Now we simplify this. So do we have like radicals? No, we do not. So we can't add these together or subtract these yet. What we do then is we simplify. Can we break up rad 36? Well, yeah, 36 is a perfect square. So the square root of 36, that just becomes 6. And then rad 24, is there a perfect square that goes into that? Yeah, 4 does, right? So we can break this up. So the 5 we keep out front. The rad 36 we change to 6 because the square root of 36 is 6. Negative 15 stays out front of this radical over here. And then rad 24, two radicals that multiply together to make 24. One of them has to be a perfect square. That's rad 4 and rad 6. So again, 5 stays out here, 6 stays here. Negative 15 we leave out front. The rad 4, the reason we chose 4, it's a perfect square, so that becomes 2. And then rad 6, we can break that up into rad 2 and rad 3, but neither of those are perfect squares, so it doesn't matter. That won't simplify this, so we just leave it rad 6. Now what we do is we combine these, so 5 times 6 gives you 30, negative 15 times 2 gives you 30 as well. Since this has a radical and this doesn't, don't try to subtract these, just leave this as your answer. Here, we have 3 rad 11 plus rad 7, the quantity squared. So this is going to help you if you rewrite it as 3 rad 11 plus 7 times 3 rad 11 plus 7. Now you see that you are in charge of foiling it. You don't want to just square each term. That's not how that works. 3 rad 11 plus rad 7 squared looks like this. Now we foil. So we multiply the first terms together. What's 3 times 3? That's 9. What's rad 11 times rad 11? That's rad 121. Then we multiply the outer terms together. What's 3 rad 11 times rad 7? Well, you multiply what's under the radical together, so that becomes rad 77. So it's plus 3 rad 77. Multiply the inner terms together. You get the same thing. When you multiply these two together, multiply what's under the radical together, you get rad 77. The 3 stays out front. Lastly, you multiply the last terms. Rad 7 times rad 7, rad 49. Cool. Now let's simplify. So we're going to go ahead and combine like terms. Since in here we have a rad 77 and a rad 77, we can actually add those coefficients together. So we keep this rad 77 and we add the coefficients. What's 3 plus 3? That's going to be 6. So we have that. We then tack this 9 rad 121 on the front and the plus rad 49 to the back. Now, none of these are like radicals. So what we do is we simplify. This 9 stays out front. The square root of 121. Oh, that's a perfect square. So that just becomes 11. Awesome. This stays plus 6 rad 77 because rad 77 we can break up into rad 11 times rad 7, but neither of those are perfect squares, so this is as simplified as that gets. Square root of 49, that is also a perfect square. Look at that. So that becomes 7. Now, the 9 times the 11 becomes 99, and I can combine the whole numbers here. So 99 plus 7 is going to give me 106 plus 6 rad 77. Now, rationalizing the denominator. So if the denominator is a monomial with a radical, rationalize it by multiplying the numerator and denominator by that radical. So here, if I have 7 over rad 6x, this is a monomial, it's just one term, there's no plus or minus. So what I do, I just multiply the numerator and denominator by rad 6x. Now in the numerator, I just get 7 rad 6x. In the denominator, I multiply what's under the radical together, I get rad 36x squared. Now to simplify this, I take the square root of 36 and I take the square root of x squared. So I get 6 and then the square root of x squared, absolute value of x. Remember, because I'm going from an even exponent to an odd exponent, need the absolute value. If the denominator is a binomial with a radical, you rationalize it by multiplying the numerator and denominator by the conjugate of the denominator. So here, I have a binomial in the denominator that has a radical. It could have one radical or two, like this. It doesn't matter. Either way, you rationalize it by multiplying by the conjugate. What's the conjugate of rad 2 minus rad 6x? It's rad 2 plus rad 6x. And you have to multiply that to the numerator and denominator. It's because that's technically multiplying by 1 because it's the same thing over the same thing. So it doesn't really change your fraction. So now we need to multiply. In our numerator, we're going to distribute 7 times rad 2 is going to be 7 rad 2. 7 times rad 6x, 7 rad 6x. Sweet. In the denominator, we have a binomial times binomial, so we got to FOIL. Multiply the first terms together. Rad 2 times rad 2, rad 4. Multiply the outer terms together. Rad 2 times rad 6x, rad 12x. Multiply the inner terms together. Negative rad 6x times rad 2 is going to be negative rad 12x. Multiply the last terms together. Negative rad 6x times positive rad 6x is going to be negative rad 36x squared. Here, the middle terms are going to be like terms, like radicals. You can see that. Yes, they have the same radicals. They have opposite coefficients though. One's plus 1, one's minus 1. So those are going to cancel each other out. The square root of 4 becomes 2. The square root of rad 36x squared, just like up here, becomes 6x. And then the x is in an absolute value because we go from a x squared, an even exponent, to an odd exponent to the first power. Now, example 4, we're simplifying each quotient. So here, we have 5 over rad 7 minus rad 3. So we got to multiply by the conjugate to the numerator and the denominator. So our conjugate, instead of being rad 7 minus rad 3, it's going to be rad 7 plus rad 3. So in our numerator, we distribute 5 times rad 7, 5 rad 7. 5 times rad 3, 5 rad 3. Sweet. In our denominator, we got a FOIL. So rad 7 times rad 7, rad 49. Rad 7 times rad 3, rad 21. Negative rad 3 times rad 7, negative rad 21. And then negative rad 3 times positive rad 3 is going to be negative rad 9. We then simplify. Like terms in the middle. Since they are opposite coefficients, those are going to cancel each other out. The rad 49 becomes 7. The rad 9 becomes 3. And then we can simplify these. 7 minus 3 just gives me 4. Again, we don't simplify in the numerator because those are not like radicals. In part B, we're doing the same thing. We have a denominator that has a radical in it, and it actually has 2. And since it's a binomial, we need to multiply the numerator and denominator by the conjugate of the denominator. So what would be the conjugate of rad 6 plus rad 11? That would be rad 6 minus rad 11. So we multiply that to the numerator and denominator. In the numerator, we distribute negative 2 times rad 6 is negative 2 rad 6. Negative 2 times negative rad 11 is positive 2 rad 11. In the denominator, we FOIL. Rad 6 times rad 6, rad 36. Rad 6 times negative rad 11 is going to be negative rad 66. Rad 11 times rad 6 is going to be positive rad 66. And then rad 11 times negative rad 11 is negative rad 121. Now we combine like terms in here. The rad 66 and the rad 66, one is a negative 1 rad 66. The other one is a positive 1 rad 66. So those are going to cancel each other out. Here, the rad 36 becomes 6. The square root of 121 we know is 11. So we get 6 minus 11 in our denominator. Our numerator, those are not like radicals, so we're not going to be able to combine those. So that stays like that. 6 minus 11 in our denominator becomes negative 5. And you can leave your answer like this. This is technically correct. Or if you don't like having a negative in the numerator and denominator like this, some people don't, you can multiply it by negative 1 over negative 1. Since it's still a form of 1, it doesn't really change your answer. It just makes it so it looks a little nicer. So if we multiply by negative 1 over negative 1, the denominator becomes positive 5, and the numerator becomes 2 rad 6 minus 2 rad 11. So that is the same thing as this. Okay, these are both correct answers.
What does a skater do when they get angry? They kick flip out. You try.
Okay, here, again, we can't have a radical in the denominator. And since it's a binomial, we're going to go ahead and multiply by the conjugate of the denominator, which instead of rad 3 minus rad 2, it's going to be rad 3 plus rad 2. And we have to multiply that to the numerator and denominator. That way, it's a form of 1, the same thing over the same thing, so it doesn't really affect the problem. Here, we distribute in our numerator. We multiply the 10 times the rad 3, you get 10 rad 3. Multiply the 10 times the rad 2, you get 10 rad 2. In the denominator, you're going to FOIL. So we multiply rad 3 times rad 3, you get rad 9. Multiply rad 3 times rad 2, you get rad 6. Multiply negative rad 2 times rad 3, you get negative rad 6. And then multiply negative rad 2 times rad 2, you get negative rad 4. Now our like terms in here, they have the same radical but opposite coefficients. So they're going to cancel each other out. And the rad 9 and the rad 4, we can simplify to 3 and 2. Now look at that. There's no more radical in the denominator, so all I have to do is just combine the 3 and the negative 2. So 3 minus 2 gives you 1, which you don't even really have to write this over 1. You can just write it as 10 rad 3 plus 10 rad 2. Again, can't combine these because these are not like radicals. Down here, again, we have a radical in the denominator. So to rationalize, since it's a binomial, we have to multiply by the conjugate of the denominator. So what's the conjugate of 2 plus rad 5? It's going to be 2 minus rad 5. And we have to do that to the numerator and denominator. In our numerator, we distribute. The rad 5 times 2 gives you 2 rad 5. The rad 5 times the negative rad 5 is going to be negative rad 25. Then in the denominator, we FOIL. So 2 times 2 gives you 4. 2 times negative rad 5 gives you negative 2 rad 5. Rad 5 times 2 is going to give you 2 rad 5, and then rad 5 times negative rad 5 is going to be negative rad 25. In our denominator, we have like terms. So this rad 5 and this rad 5, same radical, but opposite coefficients. So those are going to cancel each other out. In our numerator, this rad 25 becomes 5. This rad 25 also becomes 5. This 4 stays 4. Now, what's 4 minus 5 in our denominator? That's going to be negative 1. What we can do is divide each of these terms in our numerator by negative 1 to simplify. So this becomes negative 2 rad 2. This becomes positive 5. Most people don't leave it like this. You usually want your radical to come second, so you can rewrite this by flipping these two and just making it 5 minus 2 rad 2. Again, either of these are correct, but this is usually the proper form to put it in.